Greetings and welcome. Today's lesson we're going to talk about factoring. And factoring is essentially the undistributive property. The first thing I'd like us to look at is just a little recall problem in which if I was distributing 2x into a monomial into like a trinomial or a binomial or whatever, let's actually make it a trinomial, x squared plus 5x plus 1. What we would do is multiply it into each of the terms, and we would multiply coefficients and add exponents anytime we multiply the same bases. So 2 times the 1 here, the invisible hobbit wearing a ring, would be 2. X squared times x is x cubed. 2 times 5 is plus 10, x times x is x squared, and 2 times 1 is 2, and x times x to the 0 would be x to the first. And this would be our answer, right? So remember, that's how we used to do that. So factoring, as I said, is undistribution in a sense, where I'm writing an expression as the product of lower degree expressions, essentially. So if I wanted to factor this expression, what if I've got 12x to the fourth y squared minus, let's say I've got 15x cubed y to the fifth. And if I want to factor this expression, the first type of factoring we do is called greatest common factoring, in which I'm going to steal the greatest common factor from each of these terms and write it outside a set of parentheses, essentially undoing what we had up here. So between the numbers here, between 12 and 15, the greatest common factor, I believe, is 3. Between the variables, x to the fourth and x cubed, at most I could take out an x cubed. And between y squared and y to the fifth, the most I could take out is y squared. So I will write that on the outside of a set of parentheses, and on the inside is going to be written what remains, or what would I multiply this by in order to get 12x to the fourth y squared, right? I technically could also word that, what is 12x to the fourth y squared divided by this equal to, and that would be written there. So 3 times 4 is 12. X cubed times x would give me the x to the fourth, and y squared is already present, so I don't need any more y's. And then for the second term, this times what would have given me this term. So this is negative, and a positive times a negative would equal a negative, so it must be negative. 3 times what is 15? That's 5. X cubed is already present, so I don't need it anymore. And y squared times y to the third would be y to the fifth. So this would end up being my answer. And sometimes you'll be able to factor the inside of the parentheses further, but at this point, this greatest common factor type of factoring, we won't have to worry about that just yet. So that's the first kind of factoring, is being able to do that. The second kind will come from a second type of recall, and this is the kind that we're going to spend a lot of time on. Where, imagine if I was multiplying x plus 2 times x plus 3. And if I was multiplying this out, I would distribute this x times both of those terms and the 2 times both of those terms, and I would multiply like so. So x times x is x squared, x times 3 is plus 3x, then plus 2x, and plus 6. And then we'd be able to combine some like terms where the 3x and the 2x, I can combine them adding their coefficients. So x squared plus 5x plus 6 would be my answer if my goal was to multiply or distribute. And factoring, as I said, is undistribution. So how could I rewrite this? How could I bring this backwards in this direction? How could I bring it back to the product of lower degree expressions, right? How could I bring it to smaller things being multiplied. And let's analyze real quick to figure out where some of this stuff come from. So this x squared term, where did that come from? Well, that came from the term above it, which came from the product of the x and the x, right? So if I'm going to have an x squared, specifically with a 1 as its coefficient, I know that I'll have an x and an x written inside parentheses. Now let's look at the 6. So the 6 came from the product of the 3 and the 2. These last numbers, the lasts, if I was thinking of it as far as FOIL, being multiplied. And so that's where the 6 comes from, the product of these two numbers. And then where did this 5 come from? The 5 came from the 3 and the 2 here, which was directly those two numbers there, right? So it's the sum of these two numbers. So let's write down some little rules for factoring. So factoring, specifically x squared plus bx plus c. So if I'm factoring some quadratic x squared plus bx plus c, I'm going to have, let's see, x plus some number, I'll call it s1, times x plus some number. And these two numbers, I know that they have to multiply to be the c term, and they have to add to be the b term, right? So I guess I could write down those facts. So I know that c is equal to the product of those numbers, and b, the coefficient of my linear term, is equal to their sum. Now, if I want to use these facts, like solving some sort of mystery, how I could get it written in this form, the more restrictive or the more conclusive fact that's going to help us out is this product one. Because especially if I'm limiting this just to integers at the time being, there are only going to be so many factors of c, or so many numbers that multiply to be c. And as far as the sums of integers that add to b, I mean, if b was the number 2, for instance, I could have 1 and 1, or I could have 0 and 2, or -1 and 3, or -2 and 4, and there'd be infinitely many solutions that would work there. So this is less restrictive of a fact. So what we're going to do, step 1, is find the factors of c, right, coming from that first fact. Little quotes around c there. And depending on the sign of c, if c is positive, then I want the factors of c that will add to be the b term. However, if c is negative, I'd want the difference of those numbers to be the b term. So I'm going to say that add or subtract to c, or sorry, to b. Right? So that's how I'm going to pick these two numbers. But now the only other thing that I'd have to pick is the signs associated with those numbers. There's just a couple facts that I can use to help me determine the signs of each of those. And let's see, a couple things we can consider. So if c is positive, then I know the signs must be the same. Okay, so here's, I guess, case 1 that I could consider. C is positive, signs are the same. And if B is positive, still in the same case, then, and the signs are the same, two positives are the only way I can get two numbers to add to be another positive. And similarly, if the signs are still the same from C being positive, if B is negative, then both of those must be negative. So there's our first case. If C is a positive number, then the signs are the same, so it's either plus plus or minus minus for these two symbols here. And then the other case is case 2. If c is negative, then signs are different. And then the sign of b will help us determine the remaining facts. So if b is positive, then the most influential is positive. Another way you could say that more mathematically is the one with the greater absolute value will be positive. And then if b is negative, the most influential is negative. All right, so let's do a quick example of how to factor when our coefficient is positive 1. So if I want to factor the expression x squared plus 6x plus 8. So what I'm going to do is find the factors of 8, my c term, so 1 and 8, 2 and 4, and which of those in this case add to be 6. So that's going to be the 2 and the 4 that add to be 6. So my answer is x with a 2, x with a 4, and now I have to determine their signs. Now 8 is positive, so two numbers have to that multiply to be positive must have the same signs. And if it was minus minus, that would not add to be a negative, or sorry, add to be a positive 6. So the signs must both be positive. So this would be my answer. And I could do a quick check by multiplying this out or foiling it, and that would work just as well. Here, let's do just one more, I think that I'll have time for. X squared, let's say I have plus 4x, and let's do minus 12. So find the factors of the c term, 1 and 12, 2 and 6, 3 and 4, and I'm looking for which of these factors subtract, in this case, to be 4. So 1 and 12 subtract to be 11, 2 and 6 subtract to be 4, and 3 and 4 would have subtracted to be 1. So I'll write x with a 2, x with a 6, and now to determine the signs have to be different because they multiply to be negative here. But they add to be positive, so the more influential of 2 or 6 must have been my positive number, being the 6. And then 2 must have been negative. And that would be the factored form of that quadratic. Alright, thanks for watching this video, and look forward to seeing you guys next time.